Determine if the series converges or diverges. We have the sum from n equals 1 to infinity of 4 divided by the square root of the quantity n squared plus 3. In this example, we'll be using one of the two comparison tests on the right. Let's first determine what series the given series resembles, and then if the series converges or diverges. The given series resembles the sum from n equals 1 to infinity of 1 divided by the square root of n squared, which simplifies to the sum from n equals 1 to infinity of 1 divided by n, which we should recognize as a harmonic series and therefore diverges. Or we can also say the given series resembles the sum from n equals 1 to infinity of 1 divided by n, which diverges by the p-series test with p equals 1, which is less than or equal to 1. Looking at a sub n, I think it'll be easier to use a limit comparison test, where for a quick review, if we have two infinite series, one given by the formula a sub n, and the other given by the formula b sub n, where a sub n and b sub n are both greater than 0, if the limit as n approaches infinity of a sub n divided by b sub n equals L, which is greater than 0, then both series converge or both series diverge. So because we're comparing to a divergent series, if this limit equals L, which is greater than 0, then we know the original series also diverges. We'll let a sub n be the formula for the given series, and b sub n be the formula for the series we're comparing to. So again, applying the limit comparison test, we need to find the limit as n approaches infinity of a sub n divided by b sub n. Writing the quotient as a product, instead of dividing by 1 divided by n, we multiply by n divided by 1. Multiplying, we have the limit as n approaches infinity of 4n divided by the square root of the quantity n squared plus 3. Even though we have a square root in the denominator, we know the square root of n squared is equal to n, so we can think of the denominator as having degree 1, and the numerator has degree 1, and therefore the limit as n approaches infinity is equal to the ratio of the leading coefficients, which would be 4 divided by 1, or 4. And because 4 is greater than 0, we know by the limit comparison test the given infinite series diverges. Before we go, I do want to point out, notice here we used b sub n equals 1 divided by n for the comparison. We could have also used 4 divided by n, because 4 times a divergent series is still divergent. I hope you found this helpful.